In general, to solve the absolute value of ax plus b equals k, you need to solve the following two equations: ax plus b equals k, or ax plus b equals to the opposite of k. Notice in the first equation k is positive, and in the second equation k is negative. To help you understand this better, let's look at some examples. In example 1, we have the absolute value of 2x plus 1 equals 7. Following the definition above, we can rewrite this problem as two equations. 2x plus 1 equals 7, and 2x plus 1 equals negative 7. We will solve the first equation by subtracting 1 from both sides of the equation. Next, we divide both sides by 2. This gives us x equals 3. For the second equation, again, we start by subtracting 1 from both sides. Again, we divide by 2. This time we get x equals negative 4. Therefore, we have two solutions, negative 4 and 3. Note that you can check your solutions by substituting them back into the original equation to see if you get a true statement. In example 2, notice on the left side of the equation we have the number 5 behind the absolute value. In order to use the definition above, we need to see only the absolute value on the left side. This means we will have to get rid of the 5 by subtracting it from both sides of the equation. This will give us the absolute value of x plus 3 equals 7. Now we can apply the definition to solve this equation. Again, we rewrite the problem as two equations. X plus 3 equals 7, and x plus 3 equals negative 7. We solve the first equation by subtracting 3 from both sides. This will give us x equals 4. In the second equation, we also subtract 3 from both sides. This time we get x equals negative 10. Therefore, we have two solutions, negative 10 and 4. Here we have a different kind of equation. This equation involves two absolute values, one on each side of the equal sign. To solve this kind of equation, you need to rewrite the problem as two equations as well. Ax plus b equals cx plus d, and ax plus b equals the negative of cx plus d. Let's look at an example. In example 3, we have the absolute value of x plus 6 equals the absolute value of 2x minus 3. We rewrite the problem as x plus 6 equals 2x minus 3, and x plus 6 equals the negative of 2x minus 3. We begin by solving the first equation. First, we subtract 6 from both sides of the equation. Next, we subtract 2x from both sides. We now have the opposite of x equals negative 9. Note that the negative sign in front of the x is really a negative 1. So we proceed to get rid of the negative 1 by dividing by negative 1 on both sides. This gives us x equals the 9. In the second equation, we first have to find the negative of 2x minus 3. Again, recall that the minus sign in front is really a negative 1. Basically, all you need to do is multiply both terms inside the parentheses by negative 1. Doing so will turn our equation into x plus 6 equals negative 2x plus 3. Next, we subtract 6 from both sides, then add 2x to both sides. This will give us 3x equals negative 3. The last step is to divide by 3 on both sides. This gives us x equals negative 1. Therefore, our two solutions are negative 1 and 9. When solving absolute value equations, sometimes we run into special cases. According to case 1, the absolute value of an expression can never be negative. However, sometimes you may see an absolute problem that is set equal to a negative number. When this happens, the absolute value equation has no solution. Case 2 indicates that the absolute value of an expression equals 0 only when the expression is equal to 0. What this means is that you will only have one equation instead of two when you rewrite the problem. The reason for this is that if you look back at the first definition we discussed, when you write your two equations, one equation should equal positive k and the other should equal the opposite or negative k. However, when k is equal to 0, there is no such thing as positive or negative 0. 0 is simply 0. Let's look at some examples. In example 4, we have the absolute value of 5x minus 3 equals negative 4. Notice the absolute value equation is set equal to a negative number. According to case 1, this cannot be. Therefore, we say that this equation has no solution. Note that the symbol for no solution is a 0 with a slash through it. In example 5, we have the absolute value of 7x minus 3 equals 0. This is an example of case 2. Notice that the equation is set equal to 0. This means we will only have one equation, 7x minus 3 equals 0. To solve this equation, we add 3 to both sides of the equation and divide by 7 on both sides. This will give you the solution x equals 3 over 7. You should look over the examples on the web page and then test your knowledge using Test Yourself.